Hello, ladies and gentlemen. Thank you for flying Air Math on this beautiful day. What we are going to be looking at is an introduction to Chapter 2, which is linear equations, and we are going to look at slopes and rates of change. So our goal for today is to find the rate of change from a graph, and we're also going to find slopes. So let's define a few things first and foremost. What is a rate of change? Well, rate of change allows you to see the change between two quantities that are different. Now, at first you might say to yourself, that seems very odd. I don't understand entirely. Well, remember, you use this every single day of your life. You say miles per hour, how fast is the car going, etc. Well, that is miles per hour. So it is a rate of change because we see the change between two quantities, how much miles change in and how many hours that change as well. So clearly you could say something like this: oh, he drove 300 miles in 3 hours. And that would be absurd. However, that is exactly what we just, that this is a rate of change, an exact example of that. So clearly this person's driving 100 miles per hour, which would be absurd. But there we go. On average, by the way, that's an average. So that is rate of change. Different. Notice I would not say a rate of change like 12 inches in 1 foot. That's actually not a rate because they're both distances, because you could still convert these to be the same. Right here, 12 inches to 12 inches, and you get 1. So this is actually called a conversion. It is not a rate. A rate has to have a different type of units down below. Okay, so it's a change in the dependent variable. Usually we say y. And divided by the change in the independent variable. And that's usually x. Now, before we go on, I do want to define what slope is. Now, slope, there's a couple different ways to describe slope, but slope can mostly be defined, or you can simply say the steepness of the line. Steepness of a line. So, for example, this line is very steep, and this line is very shallow, right? It's going up just a little bit, but they are... the slopes are clearly different on this one. Okay, so let's walk through how we find slope. So we always tend to use the letter M for slope, and a fancy way of saying it is this: the change in y divided by the change in x. And this symbol right here is learn to speak, mathematician speak for change. It's the Greek letter delta, as in our capital letter D. All right, now how we say that is when we have 2 points, it's y2 minus y1 divided by x2 minus x1. And let me just write that out. This is x1, y1, and then you have x2, y2. So you have 2 separate points. This one's xy, this one's xy. And so the 1 just means your first point, and this is your second point. So how much does the change in y occur, and what's the change in x? Let me show you again what that means. Another way of writing this is how much does it rise, the line, compared to how much does it run. So let's look at a quick graph. Let me just sketch something right here. And I just have some 2 random points right there, here and here. So what we're doing is, well, to get from one point to the other, how much change occurs. So what we do is we count what the change in the y is. So this is my change in y. And then we compare that to the change in x, and we just count that over there, and the change in x. So this is where we get slope from. Okay, so let's describe a situation in the graph, and then we want to find the rate of change. So days and costs. Days change, 1 day, 2 day, 3 day, And here is the cost, and it's going up pretty much at the same rate here. So what's an example of this? Well, it could be something like a vacation, right? Or rental cost. So I'll just say something like this. It's a rental cost for an apartment, right? For a couple days. So what's that mean here? That means on day 1 we pay 60, but day 2 we only pay a little bit more, and day 3 we only pay a little bit more, day 4 we only pay a little bit more. Now maybe that's not going to be a right description for an apartment. Maybe it's like a kayak or something, or bicycle renting, because it's only a couple dollars there. So, but that would be at least a good idea. Rental cost, in other words, in the number of days we spend this, in 5 days we spend $120 to rent this apartment, and I'm going to say it's a very cheap apartment. Okay, so now let's actually find the rate of change. Find the rate of change. What we do is choose 2 nice points here. So I'm going to choose this point right here because that location is at 160. Okay, clearly that's a very nice point. And then this one here is a very nice point too, and that one's at 120. Okay, so I'm just going to go ahead and count how much change occurs here. So we can just count up how much it gets to here. And I'm not counting squares, I'm counting the units, right? This goes up by 20, another 20, and another 20. So my slope, or in this case, the rate of change, we say, rate of change, is going to be, when we just count, so let me count. This goes 20, 40, 60. So it goes up 60. Up 60. So we say that's 60, and more specifically $60 over, and now let's compare how much it goes, the days increase. Day 1, it's good, that's 1 day, that's 2 days, 3 days, and 4 days. So the change is 4 days. 4 days. So the final answer here, when we divide, we get $15 per day, or we can write it as $15 per day, like so. So, wait, what does that mean? Well, if we were just to unpack this a little bit further, the rental cost for the apartment, day 1 gets you in the door and you have to pay $60, but you can stay for another $15 additional. So that's a good way to extend your stay, or people might encourage you to extend your stay because you're staying, it's less expensive to stay a little bit longer. All right, your turn now. Your turn down here. You're doing the exact same thing here, and you are going to describe down here and then find the rates of change. So pause the video and come back and check what the rate of changes are. And here are the answers. 3 points per basket, 5 seconds per mile, and 16 feet per second, okay? Because it's this feet per second over seconds. All right, now let's take a few moments and look at what it means to be slope. And there are a couple different things to consider here. Slopes of lines. So a line with a positive slope slants upward from left to right. So as you read in English, from left to right. So something like this, and it doesn't have to be anything special, but there we go. As I go to from left to right, it goes up. So a line with positive slope slants upward from left to right. All right, so what do you think here? Dun, 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 dun. Downward from left to right. Well, let's think. That's probably a negative slope. Yay for negative slope. And that's going to look something like this, that as I read from left to right, it goes down here. Okay, a line that has a slope of 0 is going to be a flat line. The slope of 0 is horizontal. Okay, now this one over here, A line that is undefined is a vertical line. What? What's undefined? Where did that come from? Well, remember one rule, the big rule in math, is that we cannot divide by 0. So for example, if I got 12 divided by 0, I was calculating slope, then I would not stop and say that. I would not say, oh, my answer is 0 or 12 divided by 0. No, the answer is undefined. Because we cannot divide by 0, that's my answer, undefined. The slope is undefined. The line is vertical. Over here, if you got a problem that said something like this, 0 was in the numerator, then we would say slope is 0. So in this case, m equals 0. The slope is 0. The line is horizontal. All right, so what about a roller coaster? And I found this on a YouTube video. And it was something like this. Here we have a roller coaster here, and it goes up there, and then flat there, and then down there, and then flat again, and then it comes up. Now clearly it's not going to be that jagged there, and then like that. All right, so let's see here. So here we've got the roller coaster, and what's it doing? Well, it's at a 0 slope, because it's not really any fun, right? 0 fun. It's just kind of going forward. Now it goes up here, so it's a positive slope. And then here we have a 0 slope again, or the slope of 0. And then it comes down here in a negative, whoa, slope here. And then here again, it flat lines to a 0. And here we have a positive again, and I'll just use plus there. And this one is, you drop straight down, and that just is undefined, like it's crazy. It's ballistic, or whatever term you want. All right. So let's find slope. So two ways we're going to look at it is we can just do a simple counting as long as my units, and we have to consider our units, and we can just count the rise over the run, but we can also substitute into our handy-dandy formula. So let's do example number 2 here, and we're just going to count the rise over the run. We always use the letter M, and all we're going to do is count from one point to another. So it doesn't matter which point you start with. I could start here and go to here, or I could go start here and go that way. The important part is that you're consistent. So let's go from here. And notice my units are 1, 2, 3, to 4, 1, 2. Good. So that means each box here is a 1 by 1. So I can count just my ones. So let's do that. Let's start from here and count how much I go down. So 0, 1, 2, and 3. So that's down 3. So we say negative 3 there. Well, how much right do I go? And again, right is positive and left would be negative on a number line. So here I go positive 1, positive 2, or right 2. And there we go. So this one here is a positive 2. So let's finish this up and simplify it. And in the end, my slope is negative 3/2. Negative 3/2. Oh, but Swenson, I thought you had the negative on the top. You're right, I did. But notice this, if I were to start counting and go the other way, watch the magic here. So let's say I start at this point right here, and I count up 3. That's a positive 3. But now we count left 2. That's a negative. So notice no matter which way we had done it, had we said a positive 3 over a negative 2, the answer is still the same. Why? Because my negative can now be just come out in front of the fraction there. So it doesn't matter which one you start at. The important part is that you know your directions, up, down, left, right, which one's positive, which one's negative. All right, so now let's substitute into our formula. Our formula, as we saw earlier, was y2 minus y1 over x2 minus x1. Again, what does this mean? It means I take the second y and I subtract the first y. So if I am calling this one my second y, that's my 2 there, the 1, and I'm going to subtract that 4 there. So we have a fraction bar, and we're going to do some subtraction here. So I say 1 minus the 4. Okay, so what about the other one? The x2 is this one. My second x is the 2, and my first x is the 0. So we say 2 minus the 0, like that. And now we just simplify things. The numerator becomes -3, the denominator becomes 2. Great, and now I can simplify it by putting the negative in front of the fraction, right there. And there we go, -3/2. Now I do want to point out to you, had you said the other way around, that this is my second point and this is my first point, notice what happens here. Everything, or excuse me, both the numerator and denominator will switch, kind of like commutative property, but we can't really commute with our with subtraction, but we just flip them both. And in doing that, the top is +3, the bottom is -2, and look where it takes you, the same thing. So the important part is being consistent. It doesn't matter where you start, but if I start here, as in 1 minus 4, then I need to do 2 minus 0. Or if I did 4 minus 1, then I have to come back here and do 0 minus 2. All right, notice that gave me a negative slope, and I expected that, right? Because as I read, this went down, so it was a negative slope, hence the negative right there. This one's clearly a positive slope, so whatever my answer is, whether it's a fraction or an integer, we are going to have a positive answer. We don't need to write the plus, but that's just in my mind. I'm thinking about that. Okay, so let me count, and let me just double check my units here, right? So this one here goes down 2, sorry, excuse me, down 1, down 2, down 3, down 4. Good. And this one here is 1 and 2. So my units are the same. So I'm just going to count from one place to the other. So starting here, it goes, starting at this one, it goes up 1, up 2. So that's a +2. So my slope is, and I like to use my plus there just so that I know it's an up. Okay, and then what about this other one here? This one goes right 1. So that's also positive, a +1. And so in the end, my answer is 2 flat, just 2. And there we go. Notice I don't need to write it. In fact, I shouldn't write it as a fraction. I interpret it as a fraction up to right 1, but I don't write it as a fraction. I always simplify my fractions. All right, now let's do this a little bit faster, but I'm going to start by writing my supersecret formula. Why do I do that? The reason I do that is so that I can memorize it. So I'm going to plug and play right here, and I'm going to say 1 minus a -1. Again, where did I get that? This 1 minus this -1, divided by, and then the x's, -1 minus a -2. -1 minus a -2. And some of you say, but Swenson, couldn't I have just said 1 plus 1 on the top? And the answer is yes, you could have. But I suggest always putting the negative here, the minus there, so that you know it's minus and that you remember it always as subtraction. Okay, now I can take care of double negative material here. And so this one here, the top gives me a +2, the bottom gives me a +1, and the answer here is 2. So my slope is 2. Box or circle your answer. Okay. Your job is to practice A. Pause and then check your answer real quick. And the answer is 3. I do expect to see work just like I showed up there. Now do part B, practice B, pause and check. The answer here is undefined slope because we see that it is a vertical line. Vertical line, undefined slope. All right, let me walk through the example here of example 4 and 5, and then you're going to practice down below. Okay, so example number 4. Now I like to draw little lines there. That always helps me out because I prefer visual approach here. So what I'd like to do is say this -4, subtract that 5. -4 minus 5 over, and then I say a 3 minus a -2. And I do like to put those double negatives there just so I know that I always have a minus here. Okay, now we simplify. So in the numerator, I get a -9, and then denominator, I get a 5, and there's my answer, -9/5. And we just leave it like that as an improper fraction. All right, approaching this one, I'm going to do the exact same thing. 4 minus 4 goes in the numerator. 4 minus 4. And I'm going to divide by z6 minus z2. And so what we are seeing is that in the numerator we get 0, and in the denominator we get 4. And 0 divided by anything except itself is going to be 0. So we do know that this is a horizontal line whose slope is 0, but the answer is m equals 0. That's the answer, m equals 0, because that's what it asked me to find, the slope. It didn't ask me to tell me about the line. All right, please go ahead and practice 13, 14, and 15. The last thing I want to show you is, real quick, just practice graphing a little bit here. So we're going to start at a point and use this slope, and we'll let you do, we can do this all on the same graph here. So I'm going to draw one single coordinate plane, and I'm going to throw down a few numbers, not too many, because I don't want things to get overly bogged down here. So I'm just going to count by threes there, and let me clean that up. And maybe I'll throw in a 6 there as well. -6 here, +6 there. Okay, notice I don't need to go any further because I don't really have any high values there. Okay, so let's look at the first one. I'm going to do this one in red. So we start at we start at +3, -2, which is this point right there. And now the slope of 3. Oh no, what does that mean? Remember that 3 means 3 over 1. So what is it? How do I interpret that? I go up 3 because it's positive, and the 1 is positive, so I go right 3. Beware of this. Don't say up 3 over 1. The over is the fraction bar. The right is the 1. So don't say over. We don't know which way over is. Is it left or right? So use the terms right or left. So now from here, I go up 3, 1, 2, 3, and right 1 to this new point right there. And I can even do it again. Up 3 and right 1. Up 1, 2, 3, and right 1 to be at that point right there. And now we can connect the dots. La, la, la. If you're using a pencil here that doesn't have different colors, then you might want to label this one number 16. All right, now go ahead and do the other ones on the same coordinate plane.